Hello everyone. Let us see now next point, that is solution of that is application of Laplace transform. The point is solution of differential equation using Laplace transform. Okay, there are some formulas for this point. Let us see the first formula here. Let y is equal to f of t. Okay, like y is equal to f of x. Our function throughout the Laplace is f of t, that's why let y is equal to f of t. And using this formula we are going to solve the differential equations. Okay, differential equation means the equations which consist differential constants or differential coefficients, the dy by dx, dy by dx square, like that. Okay, let us see the formulas how they form. L of first formula is L of y dash. Dash means derivative here. Okay. L of I dash is first term start with minus and y of 0. First formula. And last plus s into L of y. Okay. This is the first formula. Remember that. First all terms are negative and the last term will be containing L of y. What we have to do? Just decrease the dash over here. Here one dash is there, that's why here no dash is there. And once you get y of 0, the next term will be plus, last term will be plus, and L of y, last term will contain L of y, and go on increasing the power of s. Here s power is 0, here s power is 1. This will be the last term. This is the rule. Now consider now next L of y double dash. How to start with? Negative 1 dash less than this, that is 2 minus 1, that is 1 dash. Start from 1 dash, that is y dash of 0, until we get y of 0. Next term will be obviously y of 0, and increase the power of s, that's why here s into decrease the y dash, here we get y of 0. And once we get y of 0, next term will be last term, that is plus, increase the power of s, that is s square, last term contain L of y. Okay, now third, likewise we can expand using this order or using this rule. How to find out L of y triple dash formula? That is minus, now 1 dash less than this, that is y double dash 0, bracket contains 0. Okay, these are the initial conditions. Next will be until we get y of 0, all terms are negative, minus, increase the power of s, that is s. Here s power is 0, yes, y 1 dash 0. Again next term y minus s square y of 0. Once we get y of 0, next term will be plus, last term will be plus, s power increase s cube, and last term contain L of y. Okay, in the exam we need only 3 this formula. You can expand this like this. Fourth dash, suppose dash means derivative, here y dash means derivative of y dash means first derivative, double dash means second derivative, third dash means third derivative, and so on. Now suppose y of fourth dash is minus y 1 dash less than 4, that is triple dash 0, minus s power, increasing s power, s into y less than dash double dash, next term minus s square y single dash, next term minus s cube y 0 dash, means y of 0. Once you get y of 0, next term will be final term, that is plus, last term are only plus, s raised to 4, and last term contain L of y. Understand? These are some formulas. We need only 3 formulas. These are formulas we are going to use in the solution of differential equation. Okay. Okay. Let us see the example depend on this formula. Okay. See, question is solve the differential equation. This is one differential equation, dqy by dt cube plus 2d square y by dt square minus dy by dx minus 2y is equal to 0. We have to solve this differential equation, means we have to find out value of y. Okay, our answer will be y is equal to some function of the denominator variable is t. Y is equal to some function of t will be our answer. Using Laplace transform, you have to solve this differential equation. This differential equation can be solved by any method, okay, using LD or any method, but we have to solve this equation using Laplace transform. Okay, let us see now. This is a differential equation where these are the initial conditions. Those are given in the example itself with this differential equation. Y is equal to 1 comma dy by dt is equal to dy by dt means dash, derivative of y means y dash, first derivative. Dy by dt is equal to 2, d2y by dt square is equal to again 2. At point t is equal to 0 means these are the initial conditions. Okay, solve this differential equation by using Laplace transform. Okay, now okay, let us start. The first step will be, our first step will be convert this equation into dash. Okay, d3y by dt cube means third derivative of y, that means y triple dash, plus constant terms minus plus signs, rest of the terms as it is, plus 2 into this is y double dash minus dy by dt means y dash minus 2, here no dash is there, that's why I keep that as it is, that is 2y minus 2y is equal to RHS side is 0. That means it is the most easiest example. Whenever this example comes in the exam, if RHS side is 0, irrespective of LHS side, this you can solve this as priority, because this is the easiest example. Because RHS side is 0, we don't need to solve the RHS side, that's why. Okay, now let us see. First step is you have to convert the given in differential equation into dashes, y dashes. Okay, this will be our equation. Now you have to write this initial conditions. At t is equal to 0 means bracket 0. Okay, this is y is equal to 1. This sentence means y is equal to 1 at t is equal to 0. dy by dt is equal to 2 at t is equal to 0. d2y by dt square is equal to 2 at t is equal to 0. Separately we have to write down y of 0 is equal to 1. dy by dt means y dash of 0 is equal to 2. And d2y by dt square means y double dash 0 is equal to again 2. Okay, these are the initial conditions. Now this we have to solve. Solve means finding out the value of y, function y in terms of t, this variable. Okay, now let us start with the Laplace. Now the first step will be this conversion of given differential equation into dash terms. Then second step will be taking Laplace on both side. That's what, taking Laplace on both sides, we get L of y triple dash plus 2y double dash minus this as it is equal to L. RHS side is 0, keep that as it is 0. Okay, now take Laplace inside of the term, we get L y triple dash, and at the same time you can take constant outside of the bracket or the Laplace, we get 2 outside, L of y double dash minus L of y dash minus 2 L of y is equal to 0. Okay, now we have this L of y triple dash, L of y double dash, L of y dash and L of y. Now put these formulas here. This formula we have just seen. L of y dash is this, L of y double dash is this, L of y triple dash is this. Okay, keep those formula here with the brackets. We get this is the formula for L of y triple dash plus 2 as it is. This is the formula for y double dash minus L of y dash is this formula, and minus 2 L of y as it is equal to 0. Okay, this is the third step. Now put the values here. Already in the example, y double dash 0, y dash 0, y 0. These values already given in the example. These are the values. Y of 0, y dash 0 and y double dash 0. Put all these three values here in every bracket. we get this term. Minus y double dash 0 means double dash 0 is 2, that's why it is minus 2. Minus 2, yes, y dash 0 is 2, minus s square, y 0 is 1. Here that's why it is only s square, plus this as it is s cube L of y, plus this 2 as it is, minus y dash 0 is 2, minus 2, minus s into y of 0 is 1, plus s square y L of y as it is, minus as it is here, minus as it is here, y of 0 is 1, that's why it is minus of 1, plus s into L of y as it is, minus last term 2ly as it is, L of y is equal to 0. We get this equation. Okay, try to write down the equation in one line if possible. Okay, otherwise write that one by one on second line, and at the second line write down the equation equal to 0. Okay, now simplify this. This is minus 2 as it is, minus simplify means remove the all brackets. Minus 2s minus s square plus s cube L of y minus this minus minus plus minus minus 2 to the 4 minus 2s plus 2s square L of y plus this is minus minus plus 1 minus s L of y minus 2 L of y is equal to 0. Okay, now we have to simplify this by underlining this same term, in which L of y terms are there. Here L of y is there, here L of y, here L of y, and here also. Just underline those terms by single underline. Okay, then the s terms are there and the constant terms are there. Okay, underline all those terms. Now first, from the L of y terms, take the L of y common and write down the remaining term. What is that? S cube plus 2s square minus s and minus 2. This is a common term for L of y. Okay, single underline terms gets calculated here. Now rest of the terms start from highest power of s. Here minus s square is there as it is, then minus 2s double underline, that is minus 4s, add them, and curly underline minus 2 minus 4 plus 1 is minus 5. Okay, all terms get calculated here. Now equal to 0 as it is. Okay, now here we have to find out y value, that's why keep the term y on one side and rest of the term on that side. That is a procedure. That's why L of y, this bracket as it is, take all these terms on that side. We get negative terms all positive there, we get s square plus 4s plus 5. Now we want L of y is here only, that's why put L of y as it is here, and this bracket multiplication is there, that's why on RHS side it goes to the denominator. Okay, that's why it becomes L of y is equal to s square plus 4s plus 5 upon s cube plus 2s square minus s minus 2. Now we have to find y, that's why we have to cancel this L, that's why take all L on that side, we get y is equal to L inverse of this total term. Okay, these are the main steps of solution of differential equation using Laplace transform. Now this example is example of inverse Laplace transform, and generally in all such examples of solution of differential equation, these examples can be solved using only by partial fraction method. Okay, now you can use any method here to solve this inverse Laplace transform, but this type of examples can be solved by using only partial fraction method. Okay, because these are lengthy terms, and in partial fraction only we can solve such type of examples. That's why denominator for partial fraction, denominator contains bracket multiplication. That's why we have to factorize this term. For factorization of this term, we need this synthetic division method. Write down the coefficients here, that is 1 2 minus 1 minus 2 here. Start with 1 here, 1 this one as it is, 1 into 1 here 1, 2 plus 1 3 here, 3 into 1 3, 3 minus 2 is 2 here, 2 into 1 is 2. Addition of these 2 must be 0. Okay, that's why 1 is the root of this equation, that's why s minus of this number, that is s minus 1 is a one factor of this term. The rest of the two factors can be calculated from these three numbers, that is s square plus 3s plus 2. Okay, this is a quadratic, and this can be factorized easily. 2 factors are 2 into 1. 2 plus 1 is 3. That's why the factors are s minus 1, already we have calculated above, and these two factors are s plus 2 and s plus 1. Okay, this is the synthetic division method we have already seen to factorize this denominator. That's why next step, denominator becomes s minus 1, s plus 2, s plus 1, and this can be solved using partial fraction method. Okay, a upon b upon c upon all the factors are linear factor. Okay, putting value of s is 1 minus 2 and minus 1, you will get abc value. Okay, this is the homework for you. Okay, next step, I will take the answer directly by using partial fraction method. This is y is equal to L inverse of a value is this, b is minus 1, c is 1 by 3. Okay, so all using partial fraction method in the assignments. Now take L inverse inside, we get 5 by 3 outside constant. L inverse of 1 upon s minus 1 minus L inverse of 1 upon s plus 1 plus 1 by 3 gets outside. L inverse of 1 upon s plus 2. These are exponential inverse, e raised to t, e raised to minus t, and e raised to minus 2t. This is the y is equal to some function of t is the solution of this differential equation. Now consider next example. Y double dash. In this example already they have given in the form of y double dash, y dash, and so on. That's why we have to take as it is. Y double dash minus 3y dash plus 2y is equal to 4t. RHS side is not 0 here. 4t plus e raised to 3t. Given initial conditions are y of 0 is equal to 1, y dash of 0 is equal to minus 1. Now consider this equation as it is. Write down the equation as it is. Y double dash minus 3y dash plus 2y is equal to 4t plus e raised to 3t. Now first step will be taking Laplace on both sides. Therefore take Laplace on both sides. We get L of this is equal to L of this bracket. Now take a Laplace inside the bracket, and at a time take the constants outside the bracket. We get L of y double dash minus 3 L of y dash plus 2 L of y is equal to 4 is outside. What is Laplace of t? And on next step we get 1 upon t raised to n. Here at a time Laplace and inverse Laplace formulas you have to use. That's why t raised to n Laplace is n factorial upon s raised to n plus 1 plus L Laplace of e raised to 3t is 1 upon s minus 3 on next step. Okay, now here L of y double dash, this formula is this, write down as it is in the bracket, minus 3 L of y dash is formula is this, plus 2 into L of y is as it is, and this Laplace as it is here. Okay, now we have to remove this bracket or put the values of first y of 0 and y dash of 0 here in this bracket. We get this formula. Keep the brackets, all the brackets as it is, okay, before solving that, and the RHS side as it is. Now remove this bracket, minus minus plus 1 minus s plus s square as it is, plus minus minus plus 3 minus plus minus 3 sy, first number, then s, then L of y, and last 2 into L of y, and this term as it is. Okay, now underline the similar terms, L of y, L of y, L of y, and here 3 plus 1 will be 4 and minus s as it is. Now from these three terms L of y is common. A bracket will consist s square minus 3s plus 2. This minus s as it is, and minus 3 plus 1 plus 3 plus 1 is plus 4. And rest of the RHS as it is. We are going to simplify only. Okay. Now take these terms apart from L of y on that side. We get L of y into this bracket as it is equal to this term first as it is, and this term gets opposite sign, plus s and minus 4. Okay, now before taking this bracket on that side, you have to simplify this by taking LCM. Okay, what is LCM? S square into s minus 3 will be LCM. We take the LCM of all this term. what we have to multiply all this, what will be the numerator? 4 into, just remove this s square from here, we get s minus 3, plus 1 into, remove this s minus 3 here, we get s square only, plus s into these two brackets as it is, that is s into s square, it becomes s cube and s minus 3, minus 4 into this two brackets as it is. Okay, this is the normal LCM method. Now simplify above term numerator, we get this, just 4s minus 4 3 is a 12 plus s square plus s raised to 4 minus 3s cube minus 4s cube minus minus plus 4 3 is a 12 minus minus plus 4 3 is a 12 s square. Numerator is s square into s minus 3. Now start with the highest power of s, we get s raised to 4, only one term, and s cube have two terms, minus 4 minus 3 minus 7 s cube. S square has two terms, s square plus 12s square, that is 13s square, plus s has only one term, plus 4s, and last constant term is minus 12. Okay, divided by this term as it is. Now once we solve this, take this term on this denominator, on this side, we get L of y is equal to this whole term as it is divided by this bracket. Okay, now if you y is equal to, take L on that side, we get L inverse of this total term, and for this we have to use partial fraction method, so that in the denominator we have to factorize the quadratic equation. This is the simple term, this is also a linear term, but this we need to check whether it is factorized or not. This can be factorized, obviously. This is 2, obviously minus 2 minus 1 can be factorized. It is s minus 2, s minus 1. This can be solved by using partial fraction method. Here I have written one first step of partial fraction. Consider this term as it is equal to, this is a linear term, s square. Okay, repeat 2 times. That's why for type 2 method of partial fraction we have to use for this s square, that is a upon s plus b upon s square. This is also linear, these all three terms are linear, that's why c upon this plus d upon this plus e upon this. This is the first step of partial fraction method. Next, all the steps we already studied. Okay, the LCM, taking LCM and put the values of s 1 2 3 and solve the simultaneous equation for a and b. We get all the 5 numbers. Okay, this is the homework for you. Solve this equation, you get a value is 3, b value is 2, c value 3 by 2, d value minus 2, and e value as half. Okay, once we get ABCD value, put this value in this equation and take this inverse from this equation. We get y is equal to L inverse of this term, that is this term, that is this term. Okay, as it is. Now take L inverse inside and constants gets outside, we get this term. And these are the very simple inverse. 1 by s inverse is 1, 1 upon s square inverse is t raised to 1, 1 upon s minus 3 inverse is e raised to 3t, this is e raised to 2t, and this is e raised to plus 1t. This is the, which is a required solution. Okay, so these are the second example. Now consider one more example, d plus 1. See, in this example they are given plus 1 bracket square in terms of d means derivative. Okay, derivative coefficient. Now d plus 1 bracket square into y is equal to sin t, y is equal to dy by dt is equal to 1, both the values are 1 at t is equal to 0. Two initial conditions are there. Okay, let us start from d plus 1 bracket square means expand this square, a square plus 2ab plus b square into y is equal to sin t. Now d square, take y inside, we get d square y plus 2 dy plus y is equal to sin t. What do you mean by d square y? Double derivative of y means y double dash plus 2 as it is, d of y means derivative of y single dash plus y as it is, and RHS side is sin t as it is, and these are the initial condition. Y is equal to 1 at t is equal to 0 means y of 0 is equal to 1. dy by dt means y dash is equal to 1 at t is equal to 0 means y dash 0 is equal to 1. These are the two initial conditions. Okay, now this is our original equation. Now taking Laplace on both sides, we get L of y double dash plus 2L of y dash plus L of y is equal to L of sin t. Now put all this formula here for L of y double dash, L of y dash and L of y as it is, and sin t Laplace is 1 upon s square plus 1. Now put values of y0 and y dash of 0, 1 and 1 here in the bracket. We get this term. RHS side as it is. Now remove the brackets. We get these terms. Okay. Now underline the same terms here. First L of y terms are 3. Take the common L of y. We get s square plus 2s plus 1 here. And minus s as it is. Minus 1 minus 2 becomes minus 3. Okay. All terms get covered here is equal to 1 upon s square plus 1. Now take these terms apart from L of y on that side. We get 1 upon s square plus 1 plus s plus 3. Now we have to take LCM of this step. Therefore, it becomes with L of y into this is equal to, take LCM, we get 1 in plus s into this is the numerator. Okay, as it is, plus 3 into s square plus 1. Now multiply each bracket, we get this term. Okay, now s cube start from highest term, s cube plus 3s square plus s 3 plus 1 4, denominator as it is. Okay, now take this bracket on this side. Once you get numerator denominator form on the RHS side, take this bracket on this side. We get L of y is equal to numerator as it is, denominator s square plus 1 into this bracket. Okay, now y is equal to L inverse of this term, and write down the this is a perfect square. Okay, you can factorize. This is a s plus 1 bracket square is there. Okay, this is as it is. Now by using partial fraction, you have to solve. Consider this will be your first step. Consider this factor as equal to, this is a quadratic term, as plus b upon s square plus 1 plus, this is a linear but repeated type 2 method, c upon s plus 1 plus d upon s plus 1 bracket square. Okay, now this is the partial fraction method. Solve this at this will be your homework, and take an inverse of this. We get this answer. From this answer you can predict that what will be the value for ABCD. That is, this is a cos, that's why it obviously cos, it must be, a must be minus half, b must be 0. Okay, this is minus t, c must be 3 by 2, and this is d must be 5 by 2. Okay, this is our homework. This is the answer for our question. Now here are some more homework for you. D square plus 4d plus 8y is equal to 1. Y of 0 is equal to 0. Y dash of 0 is equal to 1. Answer is this. Second, d square plus 2d plus 5 into y is equal to e raised to minus t sin t. Y of 0, y is equal to 0. dy means y dash. First derivative of y, that is y dash is equal to 1 at t is equal to 0 means y of 0 is equal to 0, y dash of 0 is equal to 1. Okay, answer is this. Here use exponential property on RHS side. While taking Laplace on RHS side, you have to remember the exponential property or first shifting property of Laplace transform. First you have to take Laplace of sin t and then apply exponential property on RHS side. Okay, and dy means derivative of y, that is y dash of 0 is 1. It's given here. Answer for this question is this. Okay, let us see now next example. D cube minus 3d square plus 3d minus 1 into y is equal to t square e raised to t on RHS side. y is equal to 0, dy is equal to 0, d square y is equal to minus 2, at t is equal to 0. These are the initial condition. First write down the equation in terms of dash. Y d cube means triple dash, y triple dash minus 3 y double dash plus 3 into y dash minus y into 1 is y is equal to t square e raised to minus t. Y of 0 is equal to 1, y dash 0 is equal to 0, y double dash 0 is equal to minus 2. Okay, this is the our original equation. Now take Laplace on both sides. We get L of y triple dash minus 3L of y double dash plus 3L of y dash minus L of y is equal to Laplace of t square into e raised to t. Okay, first we have to find out RHS side Laplace. Consider this Laplace. T square e raised to t means we have to use exponential property here on t square. What is Laplace of t square? 2 factorial upon s cube. That is 2 upon s cube. Call it as phi of s. And therefore L of e raised to t, t square becomes phi of s minus of this number, minus 1. This is by using first shifting property of Laplace, or we can call it as exponential property. Okay, we already studied all these things. Now forward is phi of s minus 1. Just replace here s by s minus 1. We get answer for this Laplace is 2 upon s minus 1 bracket cube. This is the RHS side of the equation. Put this value here. We get simultaneously you can put the formulas also. Here, this is L of y triple dash minus 3 into this is L of y double dash plus 3 here plus 3 into y. This is y dash formula, and last term minus L of y is equal to, this is the answer for this question RHS side, that is 2 upon s minus 1 bracket cube. Okay, now we have to put values of y dash 0, y double dash 0 and y of 0 here in the bracket. We get this. Already we have these numbers. Okay, put this value here. Don't remove the brackets. Keep all the signs as it is, and on next step we can remove the brackets. Okay, now here we get this term by putting the values, initial values. Now on next step just remove the brackets. Minus minus plus 2 minus s into 0 is 0, no need to write 0, minus s square plus s cube L of y plus this is minus minus plus 3s minus 3s square L of y minus 3 plus into plus, that is plus 3s L of y minus L of y, RHS side as it is. Okay, now similar underline the similar terms here. First take L of y common from this 4 term. We get s cube minus 3s square plus 3s minus 1. All the single underline terms gets calculated. Now double underline terms is minus 3s plus 3s as it is, only single term is there, and s square term is also single term, and last term constant term, that is minus 3 plus 1 plus 2, that is minus 1. Okay, all terms get calculated here is equal to RHS side as it is. Okay, now take, apart from this L of y, take all these 3 terms on that side. We get this term as it is, this term becomes minus, this term become plus, this term become plus. Right, in the higher order, start from the higher order, s square minus 3s plus 1. Now take, okay, now next step what we have to do, just take LCM of all these terms, simplify all these terms, then numerator denominator, once it get formed on RHS side, you can take this on the denominator. Okay, this is the homework for you. We can use your partial fraction method, and the last answer will be this for this question. Okay, here are some homeworks for you. d2x instead of x in some example, instead of y in some example, x can be given 2x by dt square plus dx by dt minus 2x is equal to 2 into bracket 1 plus t minus t square. Whatever it is, we have the formula for y dash, and in terms of t, denominator must contain t and numerator must contain y. Okay, if such type of equations are given, then first hint is given, first replace x is equal to y in above example. We get y double dash plus y dash minus 2y is equal to 2 into t terms are same, and here y of 0 is equal to 0, y dash of 0 is equal to 3. By replacing x is equal to y, we get the normal form of the question. We can solve this by using our regular method, and one's answer for this question will be y is equal to in terms of t. But again at the last step you have to replace y is equal to, resubstitute y is equal to x. Okay, now answer for this question is this: x is equal to t square minus e raised to minus 2t plus e raised to t. Okay, if you have any question or doubt regarding this point, you can ask me.